Hello, good morning. My name is Samuel McDermott. I am the Technical Manager for Renewable Hydrogen here at Enbridge Gas in Toronto. I work in the Business Development Group, and today I'll be talking to you about some of our renewable offerings that we have within the group at Enbridge.
Hi, and my name is Mark Simon. I am one of the engineers on the demand side management side of Enbridge, where we work with customers to help understand their gas consumption and determine ways that they can reduce their utility bill and save on energy, as well as reducing their carbon footprint. So I'm going to kick us off here by introducing our demand side management program. So what it is focused on sustainability and energy conservation. We're outward facing. We work with customers. We meet with customers. We help them understand what their consumption is during peak and off-peak times, and we try to mitigate their utility bills as best we can. So this is our agenda today. What we have here is I'm going to go through the sustainability at Enbridge Gas and go through a few of our Enbridge sustainability energy efficiency programs, which is essentially working with customers and providing a little bit of capital so they can help complete some of their projects that will in turn help them save on their gas utility bill and lower their carbon footprint. And then we're going to end with some case studies along with Q&A depending on how much time we have left. So let's get into it. Okay, so what is Enbridge Gas about? So Enbridge Gas is North America's largest natural gas storage, transmission, and distribution company. As you know, over the last couple of years, we've integrated with Union Gas. So the majority of Ontario, up to 75% of homes, are now supplied by heating and about 3.8 million customers in Ontario. So we supply heat and we supply the natural gas and heat to over 75% of the homes in Ontario. We've been around for about 170 years of experience in reliable service. And our largest hub is actually located at Dawn Storage Hub. And it's one of the largest hubs in all of North America. So what we specialize in is conservation, cleaner technologies, CNG, geothermal, and green fuels such as RNG and hydrogen, which we will be touching on a bit later in my colleague's presentation. So what is sustainability and what does it have to do with Enbridge Gas? So Enbridge Gas is a forward company, and we're innovating and we're advancing in lower carbon natural gas solutions to provide immediate and affordable ways to achieve our carbon footprint reductions. So what does that mean? That means we're reducing our natural gas consumption all across residential, commercial, industrial programs and customers through our demand side management program. We're committed to greenhouse gas reduction goals. So in a lot of our conversations and our calculations, we also provide the information on your reduction in greenhouse gas emissions. We're also driven to look for different technologies, cleaner for heat and transportation, such as CNG, geothermal, and hydrogen. Again, we'll be touching on some of those later. So Enbridge Gas is recognized as a leader in energy efficiency and conservation. Between 1995 and 2018, our energy efficiency programs reduced customer consumption by 28 billion cubic meters of natural gas. These gas savings have resulted in 51.7 million tons of greenhouse gas emissions. So essentially what the program's designed to do is to come visit with the customer, determine ways that they can use their gas smarter and use their energy in different times, peak or off peak, while we're also implementing new retrofit techniques in order to reduce gas consumption. So increasing the efficiency of models, as well as providing a little bit of capital to help these programs, to help these savings and efficiencies continue. So what I'm going to do next is introduce you to some of our particular energy efficiency programs. What we do as energy advisors is we work with the customer in order to better understand their business needs and set goals to save. So we identify and prioritize the energy projects, and then we'll also provide detailed calculated estimates on the savings of your energy sources. A few of our programs also have the capabilities of providing savings on your hydro as well as your gas side. So in cases, you will be able to also see what the savings are in kilowatt per hour as well. So we also provide technical support for new technologies and processes. For example, what has become a lot more increasingly popular in the last few years is ozone laundry for long-term care in hotels and other large residential units. And what it is it uses ozone in order to kill kill any viruses and germs, and it actually is used quite a lot now as a safe way to deodorize and clean your clothing in a mass setting with actually, and it has the capabilities of reducing your energy consumption as well. So along with this, we also provide incentives to help speed the payback up, and we provide an easy incentive process, which is collaborating with the advisor, providing a little bit of upfront information, and then typically it's just an application signature. And that is really all it takes in order to get a little bit of capital for some of your projects. So first up, we have for our customer commercial and industrial offers, we provide fixed application prescriptive incentives. The best way that I could explain this is when you go to Home Depot or something and you get an energy efficient fridge, the Energy Star is kind of what they provide the rebate on. So typically you'll go to Home Depot, you'll buy the fridge, you'll get the $500 off. So that's exactly how our prescriptive program works. We do have a brochure of offerings for items such as dock door seals, air curtains, ERVs, HRVs, and essentially you'd have to select the right one that qualifies, fill out an application and sign it, and then send it in, and it's as easy as that. In addition to this, we have our custom retrofit program, which would include, audits, site visits, operational improvements. Typically, we'll work with you. We'll take a look at some of your gas usage, any of your processes. We'll see where the big consumers are. We have the ability to normalize your gas consumption year to year and determine kind of where there is the ability to kind of reduce and save. And in addition to that, we do have the custom calculations. So a lot of our technicians are very have a technical background in this, and they'll have the abilities to accurately quantify the savings. And currently for this year, we actually have a 2-time incentive for condensing boilers. So what this means is in previous years, we were given out less dollars per the size of condensing boilers. But up until the end of June, if we have written consent that this project is going to go on, we're able to provide 2 times the amount of money. So in cases where we're paying about 10% of the boiler, we're now able to kind of boost that to about 20%, which is a huge portion. And again, these are dependent on individual companies and premises, and they are actually custom calculations. So we do take the real-time data and we figure out exactly what the new boilers are going to save. So these are designed to improve energy efficiency, lower costs, and also improve the payback period for your equipment. So to further on some of the prescriptive incentives, we're using prescriptive incentives for the purchase of energy efficiency projects, and that's what it is. It is something that is inclusive. It makes it easy for the customer. They go through the brochure, they select kind of what fits, what they need, and they know exactly what their incentive is going to be before they purchase it, which makes it very helpful. We do collaborate with a lot of the service providers and a lot of the manufacturers, so they do know that we provide these incentives, and they typically do tell the customer at the time of purchase. So again, it works like a coupon, and they're provided, and an incentive is provided with proof of purchase. And customer incentives typically cover between 25 to 45% of the incremental costs. When we say incremental costs, we say there's a base case, and it's either doing nothing or replacing it with the lowest efficiency item. So in most cases, we're able to cover a large portion of any incremental cost, and sometimes that cost is actually up to 50%, which is where we max out. Is covering 50% of the project. In dealing with service providers and distributors, we also work with them as well, and we do provide them capital as well for helping, in the order of about $50 to $100. So it's about 10% or less of what we give the customer to help implement it, and that is actually for helping us facilitate the program, working with you, gathering the information. So we do actually value our service providers and distributors, manufacturers quite a bit, and without them, obviously, this program would be a lot harder to deliver. So moving on to our commercial and industrial retrofit program, and what we do here is it is a bit more intensive. Occasionally it does entail like a site visit, an audit, a feasibility study. What we do is we pay out 20 cents per meter cube saved. So as you can see here, the sky's the limit for the incentive. It depends on what you're doing and to the extent that you're doing it. And for example, last year, I was working on a large retrofit that actually had an old steam boiler that was replaced with a new condensing boiler, and it was a giant warehouse. In addition to that, they were making some other operational improvements. They were able to save about 35–40% of their yearly utility bill, and their incentive covered about 30%. I believe it was about $30,000 that we gave for that. So they do go up to 100,000, and typically for some of the smaller commercial buildings, they won't hit that cap. But if you're an industrial user and you're up to about 500,000 meters cubed a year, you can easily get that with a 20% reduction. So what these are, again, is they are technically, these do have technical calculations. All of our reps, our advisors, our engineers, for the most part, or their technical team that actually reviews the calculations. We do have a large team of technical members, made up of engineers, HVAC people, and others that have been in the industry for 20–30 years. So we do have a lot of knowledge here, and we are looking out for the best for our customers. Another option we have here is custom audits and studies. So for one, our advisors will always be able to go to your site. We'll always be able to kind of look out for operational improvements and kind of discuss with you. But in addition, we do work with other service providers and consultants to provide audits. And what it is we pay for up to 50% of the audit or study. And how the program works is it is geared towards a certain size. So about 50,000 meters cubed and over is where we're looking for the feasibility studies. And what we'll do is we work with the service provider or the consultant directly, or the customer, however they wish, and we work on the benefits of the audit and study. So we determine their current energy costs, their current energy needs, pinpointing what they're doing right, what they're doing wrong, and where we can improve. And we establish the financial justification for these improvements. So we'll always be able to work with the customer and guide them towards the best option for their energy efficiency projects. So again, we do have operational improvements in energy management. And here we're helping customers identify and implement low or no cost operational improvements. And occasionally, so what I mean by low or no cost is putting together schedules, temperature setbacks, smart thermostats, making sure that you understand when and where you're using the most amount of your gas. And sometimes all it is just determining your on peak and off peak hours, and making sure you do a little bit of a schedule for overnights and weekends when people aren't expected to be there. Many of our buildings we see are putting in too much fresh air or not enough fresh air. But essentially having your mechanical units running 24/7 when no one's there isn't really isn't really operationally sound. So those are types of things that are sometimes best practice. Um, Zero cost, low implementation fees, and what we do is we do work with our customers in order to determine some of those. So no matter who you are or what you're doing, there is always an operational improvement or something that we can dive into, whether or not it's something that's feasible. Maybe the savings are 1 or 2%. We're just there to highlight them and let you guys know kind of what or how we could save. In terms of some of our, we've covered retrofits, but we also have an extensive plethora of new construction programs. So whether or not you're performing a retrofit or performing a new build, we do have incentives for those as well. For some of our new construction, what we do is we take the size of the planned building. Typically, it's above or below 50,000 square feet. So you're thinking, primary school is about just under 50,000. A secondary school is over 50,000. We kind of take the kind of building and we sort of guide them along the right path. And what we do here is we provide in the infancy stages of your design, and in the RFQ stage, when you're kind of writing some of these out and thinking about what are the best ways to start saving, the best time to get in with Enbridge is at the start, where we're able to provide upfront money for energy simulation with some of these big companies that kind of do determine what your actual saving, your lifelong savings will be by going from, let's say, 80% overall efficiency to 95. Including things like gas heat pumps that actually have efficiencies of over 100, and geothermal pumps, or even actually sometimes eliminating certain needs for natural gas. So these are available if there is a main natural gas line. So unfortunately, buildings like that are totally electric or other would be ineligible. But what we do is we help implement these incentives here. So the goal here is above building code, and that's probably the easiest way to describe it. Is the more you go above code, the more we're able to save you. So what our programs are designed to do here is meeting with the customer, determining what their needs are, to learn what they're looking for, learn what their overall goals are, to identify savings that could be there. It could be as easy as ensuring that their air curtains are working when their doors are open. A lot of our projects come from initiating that conversation that, hey, maybe your drive-through dock doors shouldn't be open for 2 hours, 3 hours a day. We do implement projects to put on automatic timers, high-speed door closers, and they do tend to save quite a lot of money. So the next portion is analyzing the building. What kind of building is it? Is it a warehouse? Is it a school? Is it an industrial building? A lot of our industrial processes, we are able to actually optimize how they're run. For example, dryers, industrial dryers, figuring out ways that we can increase the efficiency. Another large opportunity is steam traps, steam boilers, fixing condensate traps. We do run a lot of programs that for like steam trap audits, and sometimes those are invaluable opportunities because they do have a large opportunity to save. And then we provide the funding to actually implement these. So for now, I do have question and answer, but I would like to actually go through a couple case studies first, since we do have a bit of time here. So I'm going to go through a few of these case studies here that we've actually implemented for customers. And the first one is a condensing residential makeup air unit. What the makeup air unit is, it does drive fresh air replacement. It also does help circulate, it does help save from circulating kind of cooler air, as well as improving the overall air quality inside the building. So they do have most times they do have heat recovery. They do have condensate traps that do actually have the ability to save on your energy. And in most cases, what we do now is we install them with a variable frequency drive, which actually has the capabilities of changing the schedule so that they're not running 24/7. It's actually on a timer that is scheduled to how the building's supposed to be run. So in this case, the rooftop unit costs about $23,000. Our incentive was about $8,000, which is just under 30%. And your gas savings were almost 50,000 meters cubed a year. So that's just under $13,000 in utility bill savings. And of course, if you look at the payback, it's about 1.1 years and has a large CO2 reduction of 93,000 tons. Next up, we have condensing boiler replacement at one of our elementary schools. And now elementary schools tend to have lower consumption per unit because they aren't run quite as long and they don't have quite the population. But condensing boilers are actually quite great there. There's few gas users, so typically putting in a condensing unit can actually put a huge reduction on their gas saving. As you can see here, 39% annual reduction in their total gas consumption. And what it was is we were able to save about $3,500 a year on their gas bill, and the incentive is about $4,000. So in this case here, when we were talking about the two-time boiler incentive, that incentive is now about $9,000. So right now, it's a great deal. We're paying at 40 cents per meter cubed rather than the initial 20. So on a savings like 15,000 meters cubed a year, you're getting $9,000, which is huge because these elementary school boilers typically cost about 20,000 or less, which means we're paying for about 40 to 50% of the project. Another interesting one is building automation or recreational controls. So connecting boilers to upgrading controls on boilers, domestic hot water, integrating them with the building automation, adding automation schedules, demand control, ventilation, stuff like that. Those are massive projects. And in this case, we're actually able to implement them at the Rogers Center. And we actually implemented up to a 39% gas reduction. So quite a big structure here. And simple operational upgrades or controls upgrades can have a huge impact. So again, this is another building automation project, and this is arguably one of the larger projects we end up doing, and that's why you'll see that the incentive is $200,000. It's made up of multiple buildings and structures, so there wasn't a limit of $100,000, but we actually ended up helping the customer save 1.2 million meters cubed per year, which it is massive. If you notice, like 5,400 tons of CO2 reduction. So these are just some of the projects that we actually are able to do with our customers, and I think would benefit everyone greatly. Working with your rep, getting involved and included in some of these programs, and to be honest, it's a cost-free program that is put on by Enbridge on behalf of us, the Ontario Energy Board, and it is funded by the ratepayer. So my recommendation is to take advantage of these programs while you have them. Talk to your advisor. These are based on locality, industry. There's professionals that are there to help, and we're looking forward to speak with you guys as soon as possible.
Hello, everyone, and I am back, and I do hope that you're having a great day today, wherever you are, and whatever you're doing. So today, what I want to do is talk to you about some of the low carbon offerings that we have and are currently working on within the business development group here at Enbridge. So I have an agenda. It looks a little long, but some of the slides I'm going to skip through simply because Mark has gone over some of them already. So we'll talk about leadership and how important this is with regard to getting into the renewable energy space. We'll talk about the vision, get into some global emissions, just to give you some comparisons between locally, nationally, and globally. Then we'll talk about the offerings. We'll focus a little bit of time on RNG, some time on hydrogen. Then we'll talk to you a little bit more in depth about our power-to-gas plant, which you can see in the background there. That's how we produce our hydrogen. Then we'll get into some of the things we're planning to do. So blending hydrogen in the gas system, energy storage with hydrogen, and then we'll talk about some of the strategies that have been deployed by countries and give you some real world examples. So let's begin. So the first thing, if you're looking to companies that are getting into the renewable space, it begins at the top. You have to have buy-in. And this is pivotal for us here at Enbridge. This is what I'm showing you on the screen here is from our 2018 CSR report. And what this report says, the line that I like in there was that right at the top, our president basically and CEO basically endorses the intent that the company has to move into the green energy space. This is vital. If not, it's an uphill battle. I'm going to skip this slide because Mark went over it, but I want to jump to this one here. And the reason why I'll spend a little bit of time on this is because, as Mark said, we deliver about to 75% of the homes in Ontario. And we deliver 30% of the province's energy demand. But what I want to focus on is the second bullet and some of the other ones here. Ontario, the gas network, think of it as a massive battery going to every home, with tentacles going to every home. And the reason why I say that is because hydrogen is analogous to electricity. In other words, anything you can do with electricity, you can practically do with hydrogen. We have about 145,000 kilometers of distribution mains and service lines within our system. And we can do a lot with that in terms of carbon reduction throughout not just the city of Toronto, but throughout the province and elsewhere that we operate. Now, the gas distribution system, as an example, it peaks in the winter. And the opposite to that is that the electrical system peaks in the summer. So the electrical system at peak is about 23 terawatt hours of energy. The gas system, on the other hand, is about 81. Well, if you're going to replace all the gas systems, you're going to need to add about 60 nuclear plants generating about 5 terawatt hours of energy. Now, moving on here, what is our vision? So the vision for us is continued leadership in the low carbon space. We've been at this for a very long time. And I know people always ask me, they say, well, when did you guys start getting into solar? Well, we've been at it for a very long time. Same with wind and other renewables that we have been working on. We would like to see the connection between the natural gas grid and the electrical grid. And hydrogen enables us to do that. Carbon reduction in the gas system and diversification of the energy portfolio. So let's take a look at the world carbon dioxide emission from 2015 to 2016. And what I've done here is I've gone to a couple of sources, IRENA, which is the International Renewable Energy Agency, and our world data. And what you can see here is that power use according to IRENA, consumes about 38% of that. The next is transportation at 22%, industrial, buildings, and then others. This is fairly close to our world data. And the reason why I'm doing this is simply because I want to show that I didn't want to just take one source. I want to show you several different sources. But you can see that regardless of how you look at it, you can see how it stacks up for the different emissions in the various sectors. Now, this is from the Canadian government and 2015-2016 CO2 emissions by sector. So if you recall what we had on the previous slide, industrial here, 28%, transportation, 20%, residential, 12%, and commercial, 8%. And this is across Canada. Now, if we take a look at hard to abate sectors, again, this slide here really just shows you what I had on the first page. So I'm going to skip this slide and I'm going to go to locally what's happening here in Ontario. So within Ontario, the 2018 government GHG emission was about 165 megatons. And so by 2030, the Ontario government's target is to have a reduction of 143 megatons. And this was put forth in the government's Made in Ontario environmental plan, which outlines the pathway to do so. So you can see below low carbon vehicle up to 16%, industry performance standards, they want to get that down to 15%, clean fuels, 19%, and the list goes on and on. Now, what I've done here is I've compiled the whole thing together to show you. So on the screen here, you'll see to the left, sector and their emissions. You'll see the IRENA from 2015, our world data from 2016, the national emission for Canada in 2018, and then Ontario's. And what you see here is that transportation remains quite high. I'm not going to talk about power because the others didn't break it out that way. But you also see industrial, and you can see for Ontario how high it is. We're one of the industrial heartlands for the country. So I would expect it to be somewhat higher. And then we top off at the bottom there with buildings in Ontario 10% and 16% relative to the 12% and 8% nationally. So let's take a look at Enbridge's energy mix, renewable energy mix. So what you can see here, we have about $8 billion invested in renewable power gen since 2002. We have about 2,000 megawatts of long-term contracted renewable power, and that's enough to heat about 800,000 homes. So if you look at the bottom left corner there, you'll see a snapshot of our asset portfolio. And this is a little old now. We have been building new wind farms, and so this will be updated within the year. So 22 wind farms onshore and offshore, 6 solar energy operations, 5 waste heat facilities, a hydro facility, geothermal, RNG facilities, and CNG refueling stations, and we have power to gas, which is North America's first. We are a leader in renewable energy, as I mentioned, and the capacity is to generate 3,639 megawatts of gross zero emission energy, and that amounts to about 1,700 megawatts net. So what we're showing here is that I'm showing this slide to stress that we have been at this for a very, very long time. This is a snapshot of some of our wind assets in North America, and you can see that they're all over Canada and the United States. And this slide shows where the concentration of our solar assets are within North America. So you can see it's typically where the sunshine is. So down in Los Angeles, the US West Coast, and we have some in the horseshoe area of where we intersect with the United States on Ontario there, Canada. So let's take a look at renewable natural gas. So what exactly is it? So renewable natural gas, there are 2 ways I'm going to describe it. So you can have it from things like your green bin waste, your cow manure, and from waste from your sewer systems. And what you do is you take that and you put it into a biogas digester, an anaerobic system, and then you upgrade that. At the same time, you can take the gas from a landfill site and you can clean that gas up and have upgrade it to pipeline quality gas, which you can inject into the natural gas grid. You may ask why this is important. Well, it's actually quite smart. The reason for that is because you're creating what's known as a circular economy. As long as we're on the planet, we're going to produce waste. And some of that waste goes to landfill. And if it's going to landfill, typically what you'll do, you'll either flare it off, which is a big fire, you light it on fire in a controllable way, or you just let it rise into the atmosphere. Well, why not take that and put it back into the gas system and then have that create what's known as a circuit? It's essentially just a circuit. You eat your food, you throw out the scraps, they rot, they produce gases, you capture that gas, and you use it to cook your food again. So this is the beauty of why it is such a smart strategy. Now, our target markets are municipalities. And what you can see there on the left side of your screen is municipalities can take this renewable natural gas and you can use it to power your trucks. The city of Toronto is doing that. Food and beverage processors, they can do the same. They have a lot of waste that they can turn into renewable natural gas because it's going to decompose and it's going to create in the past they used to call it swamp gas and all that stuff, but really once you clean it up, we call it renewable natural gas. Waste management companies, these guys are already doing that and they're using it to power their trucks. And the agribusiness, they can use this, the manure from cows and their other livestock to produce renewable natural gas. So the Canadian market potential. So the future RNG potential for Canada is about 1,200 billion cubic feet. That's a lot. That's about 1,300 petajoules or about 33 billion cubic meters. So Canada's 2017, in 2017, Canada consumed 36% of the energy consumption was from methane. And that's significant. But what I'm trying to point out here is that if you're using renewable natural gas, it actually can be what's known as carbon negative, because if depending on where it comes from, if it's say cow manure or stuff like that, you're taking that and you're putting it right back into the system. So in other words, you're not letting it get into the atmosphere, you're reusing it. So business policy drivers for this. So Ontario's food waste policy is one, and the federal carbon charge is another. So municipalities that have greater than 50,000 people will have to have a curbside organic collection. So if you live in one of these larger cities, you'll have a green box in your home and you'll collect the wet waste and you'll put it out at the curb each week, as we do here in Toronto. And that goes into either a digester or somewhere where it end up producing gases. Regular enablement. Well, we've applied to the board to allow the board to recognize this. And we're happy to say that starting, I believe it's this month, we will be having a voluntary RNG supply. And what this means is that you as a customer can choose to have the gas delivered to your home being renewable natural gas. And I believe the cost for that is $2. These EB numbers you see here on the screen are numbers that you can use to go on to the Ontario Energy Board's website and you can view this publicly. So this talks about really the RNG versus electrification argument. And I'm not going to spend a lot of time on this, but the bottom line here is that we believe that you're going to need more than one technological solution to get to the 1.5 degrees C of climate reduction targets set by the Paris Accord. And then this is just an energy price comparison between various levels of fuels. On the far left, you can see natural gas. It's about $5 a GJ. It's actually trading less sometimes, down to even $3 a GJ. But on the far right, you can see where solar stands, and those prices are dropping. We're going to need all these technologies to help enable us to meet our climate targets. So one of the things that I want to point out here on the top right is that we always talk about energy in GJ in the gas world. But when you convert that to kilowatt hours, which is the unit used for electricity, you can see that 24 GJs, when we say that, that's about 9 cents per kilowatt hour, which is quite lower than the electricity that's offered in Ontario and in some other jurisdiction. But at the end of the day, I still come back to the point that we're going to need many different ways to meet our target. So some success stories is within Toronto, we have a project, 315,000 GJs, anaerobic digestion. We have one in Niagara, a landfill site, the city of London, and Hamilton as well. So let's take a quick look at hydrogen. So you probably hear people talking a lot about the different types of hydrogen, and you probably go, well, what exactly do these people mean? Or you may turn away and go, well, I kind of have an idea what they're talking about. Well, I'm about to make it all clear for you here. Brown hydrogen. Brown hydrogen is hydrogen made from coal gasification. And there's also another one, they call it black hydrogen, but really it's just different grades of coal. Brown hydrogen has less energy. You can find this in places like Germany, Australia, and you can use it to make hydrogen through gasification. Then there's gray hydrogen, which is where the predominance is for hydrogen manufacturing. And so gray hydrogen, as an example, is simply hydrogen made from steam methane reforming using natural gas. Blue hydrogen is gray hydrogen, but when you make it from natural gas, you're capturing the carbon. And so for every ton of hydrogen produced by the SMR process, approximately 12 tons of carbon is yielded. Why? Because the bulk of it is methane, CH4. So for every 4 molecules of hydrogen, you have a molecule of carbon. And then green hydrogen is hydrogen produced from electrolysis, using preferably clean electrical energy, such as wind and solar. And for us here at Enbridge, we use the electrical grid in Ontario, which is about 92 to 94% clean. So what exactly is power to gas? Well, power to gas is a process where you take electrical energy and you use it to electrolyze water and you convert it into hydrogen and oxygen. And in an ideal world, what you want to do is use low carbon clean energy, such as wind and solar, or a very clean electrical grid to split your water into its basic component of hydrogen and oxygen. A little bit about hydrogen. It's odorless, it's non-toxic, it's very light. It's about 14 times lighter than air. So if there's a fire or an escape, it has a propensity to rise fast towards the sky. It got a very, very high energy content. It's actually the highest energy content by common fuels, nearly 3 times that of gasoline. And what you have to think about is a kilogram of hydrogen is roughly equivalent to a gallon of gasoline, and it's about 0.9 gallon of diesel equivalent. Now, the converse to that is that although it has the highest energy content by weight, it also has the lowest energy content, one of the lowest energy content by volume. And this is what makes it a tricky gas to deal with. But it has a lot of benefits, and this is what's being exploited. The IEA describes on its website in an article that it's a game changer for renewables. And the reason for that is because hydrogen has an important role to play. You see, hydrogen offers long-term storage. And with a lot of renewables that are running in the middle of the night, say a wind farm as an example, where you don't really need that much power, you need long-term storage. And this is where hydrogen is able to assist. So some of the future uses for hydrogen, or the use for hydrogen, ancillary services. So in our case, what we do with our plant, which I'll talk about shortly, is we use it to help control the frequency for the electrical grid in Ontario. We also use it you can use it to enable dispatchable power. So as I say, wind and solar, really they will operate when the wind is blowing 2 in the morning. You may not need the power, but hydrogen and part-to-gas will allow you to do that. Fuel for a zero-emission vehicle, fuel cell vehicles, cars, buses, heavy-duty systems, high-quality heating, steel industry, and for us, greening the gas grid. So for hydrogen, our low-carbon energy project we have in Markham, we're a leader in that space. We're the first in North America to do so. We still are at this point. There are others that will be coming online. And what we've proved is that it's safe, it's clean, it can be cost effective, there are benefits for the electrical system, and we will continue to make Ontario a leader through this project. So the pace of hydrogen development across Canada, as you can see here, it's rapid, and we're some of the leaders in the world. It's interesting when you look at this graph here because they're comparing provinces to places like Germany, the US, China, South Korea. And you can see where the facilities for hydrogen fuel cell development is. British Columbia, Ontario, and Quebec are leaders in this. These are some of the uses of hydrogen. This is put out by the Department of Energy. And, you know, I love this slide because it talks about these are the inputs. So you can use renewable, you can use nuclear, you can even use fossil. And what you're able to do here is you can produce it through an electrolysis system. And these are all the different uses: hydrogen for vehicles, synthetic fuels, which they call, these are all what they call power to X, ammonia, metal refining, all these things you can use when you make hydrogen. You can also make power through a fuel cell and put that back into the grid. So this slide, again, just shows you some of the just expand on the previous slide on some of the things that you can do with hydrogen. And some of the higher sectors for decarbonization is where hydrogen is being earmarked. So this slide really just depicts what we're doing here at Enbridge. So we're taking the power, we're running it through an electrolyzer, we split water into hydrogen and oxygen. Currently, we liberate the oxygen, we keep the hydrogen, and one of the things we're looking to do is blend it in the natural gas grid to reduce its carbon footprint. Now, the power-to-gas plant, let's talk briefly about it. So it was built in 2018, and the intent of it was to demonstrate hydrogen production, storage, and the ability of the plant to provide frequency regulation to the IESO. That was the main gist of this plant. And then one of the things we're able to do is convert the hydrogen back to electricity using a small fuel cell. So the plant is a joint venture between Enbridge and Cummins, which is the formerly Hydrogenics. It's very stable. It's 2.5 megawatts. And we can expand that plant on that same small footprint. Probably, I think it's about 123 to 26 square meters. And we can double the output to 5 megawatts. The maximum output per day is about 1,000 kilograms or about 12,000 cubic meters per day. And this varies because, as I said before, we're providing frequency regulation services to the IESO, which is the body that oversees the electrical grid in the province. They send us the signals every 2 seconds and we have to respond. And this system can respond in less than a millisecond. The purity of the hydrogen is high, it's 99.99, and we can raise that by drying the hydrogen some more to get it to the SAE grade for fuel cell vehicles. These are some of the future use for hydrogen at Enbridge. So transportation, blending, enabling dispatchable powers, as I said, put it in the gas grid to make sure that we lower the carbon content, and feedstock. You can use it for things like ammonia, fertilizer, methanol. And it's currently being done. But when you use this kind of hydrogen, it's sustainable, it's green. Let's talk a little bit about our blending project. So we filed with the Ontario Energy Board to allow us to blend hydrogen within the gas grid to reduce the carbon footprint. And this we got last year, last October, the board gave us the green light to do so. We're on track to start construction on the 1st of April. And this will be another first within North America. And Ontario will be at the lead in this because others have announced, such as Alberta, there's Italy, there's the UK, but we'll be the first in North America to be blending to reduce the carbon content. Now, hydrogen, I talked about storage, and this graph here just shows you how much energy hydrogen contains on a per weight basis compared to other fuels. And this is by weight, not by volume. So you can see why uh, um, agencies like NASA uses it. Why? Because the energy content is extremely high on a per weight basis. Now on a per volume basis, it's quite low. This graph here just shows you different storage technologies and what you can get from them. So on the axis on the bottom just shows you the amount of energy you can store, and the vertical axis shows you for how long. So you can see a flywheel, which is extremely efficient, can store it only for probably an hour or so. Batteries, you're looking at probably a day, day and a half or so, a few days. But compressed air systems, CAES, now you're starting to get into the gigawatt scale. But if you want to get into seasonal storage and the terawatt hours, you got to get into stuff like, water pumping, hydrogen, or methane. And this is one of the beauty that is there for hydrogen. So many countries have released hydrogen strategies. I've listed about 11 here with hot links to them, but Germany, I'll call it Germany because Germany is has put some of the largest dollar figures to it. They've put about 9 billion euros, which is about 14 billion Canadian, to their hydrogen strategy. And 2 billion of that is 2 billion euros of that is earmarked to import hydrogen into Germany. Canada has theirs as well, and that was released last December. All these hot links will get you there. This slide just shows you where they'd like to be in terms of cost. And the other side is probably a better one to show you, but the prevailing thought within Canada is that we would like to get it down to $1.50 to $3.50 per kilogram. I'm going to skip this slide and give you some real world examples. So Sunline Transit in the US, this is in California, have been running transit buses for a very long time. Fuel cell electric vehicles are quite efficient compared to their ICE counterpart, the internal combustion counterparts. So the range, as you can see, is quite high, 250 to 530 miles per tank. And Zero Avia, as an example, they flew this hydrogen plane last year. Boeing has announced they've been working on 4 different models for airplanes that will be run on hydrogen. And at the bottom here, you see this Coradia Island train. Germany just ordered another 30 of these last year, and all the propulsion units come from Cummins in Mississauga, Ontario. The truck at the top there is a joint venture between Toyota, Kenworth, and Shell. A partnership in the port of Los Angeles for a dry edge vehicle. And then you have the forklifts, which companies like Canadian Tire, Plug Power have been doing, and they've deployed many, many of these. The beauty about these is that you're reducing your carbon footprint, because if you use green hydrogen or blue hydrogen, you're basically have no carbon. A fuel cell produces nothing but water, no emissions whatsoever. And this I showed really just to show you the difference between a fuel cell electric in terms of the carbon footprint emission from them. And you can see that with a fuel cell car, it's about 2.7 grams per kilometer versus a pure electric, like just a 100% electric, which is about 21 grams per kilometers. These are some of the projects worldwide. I'll focus a little bit on what we're doing in Canada. We have the 20 megawatt plant in Bécancour, Quebec. We have a recently announced 88 megawatt plant. And of course, we have the one in Markham, which is our 2.5 megawatt plant, which was the first. And that plant has been running now for about 3 years. And lastly, I want to just take a brief look at methanation. So with methanation, the intent here is you take hydrogen, renewable hydrogen, and you capture carbon dioxide or carbon monoxide coming out of a building. Instead of letting it go into the atmosphere and produce greenhouse gases, you capture that and you blend it together to get renewable methane, and you can put that right back in the system just like RNG, and you create what's known as a circular economy. This is my last slide, and really what I'm talking about showing here is this is my favorite slide, which I got from Cummins Hydrogenics. We share a lot of stages in presentations, and it just shows you what you can do with 1,000 kilograms of hydrogen. 100 fuel cell cars, doing 1,000 kilometers a day, 50 fuel cell buses, or 5 of those massive island trains that they have in Germany. So I'm going to stop there, and if you have questions, we can attend to those questions in the Q&A sessions. Thank you. I want to thank everyone today for attending and lending us your ears to listen to what our offerings are here from Enbridge. So here's hoping that you'll have a very enjoyable Springfest, and if you have questions, please feel free to reach out to Mark or myself. Thank you.
And thank you very much for taking the time to listen to Sam and myself. I would like to wish you guys all a safe and happy rest of your Spring Fest. And feel free again to reach out to either of us or at energyservices@enbridge.com. And this will get filtered to one of us, and we'll be able to deal with whatever questions you guys have. So thank you very much, and have a great rest of the weekend.